Hi, I'm Erick, lead client SDK developer at Photon Engine, and I have today Dan here with me.
Hi folks, my name's Dan. I'm a staff software engineer at Unity, focusing on multiplayer games. Back to you, Erick, take it away.
So today we'll talk about our new flagship netcode demo, a 200-player shooter at 60 ticks per second. This is how I'd like to start here. So right after we released this on the asset store, this was our very first review there. So whoever wrote this, just thank you. The team worked on this for more than a year, and everybody was super glad and super happy to see this as our very first unsolicited review. This was great to see. So let's start here with our program. So what we're going to be talking about. We'll start with some technical context of what this is all about. Then I'm going to jump into some technical details of how you actually create a multiplayer demo like this. And finally, Dan's going to come back in to talk about reaching world scale with dedicated server hosting and matchmaking. 200 players at 60 ticks per second. What does that actually mean? So Battle Royales has always been this interesting frontier. In one side, you have these super fast-paced competitive shooters like Counter-Strike, Overwatch, and so on, which are low player count, but can run really fast and very accurately. On the other side of this spectrum, you have big, large-scale MMOs, which are normally a lot slower paced, but of course can host a lot of players into the same location with compromises in some accuracy, especially on movement and speed. And Battle Royales are this thing in between that kind of bring the frontier to one side or another. So what we wanted with this demo was to change the threshold of what a Battle Royale is by making it go even closer to MMOs. So 200 players is the very highest limit ever seen in a Battle Royale, and running at 60 ticks per second, this is even more interesting because most Battle Royales run at a much lower pace. So, but these are just two numbers. What is interesting to us is also to define what it means to be a AAA grade game or demo. So AAA as a term has always been related to safety. So it is you add so many good and important features from the player perspective to your game that it is a safe bet for investors and for the company to create such a game because there is a very high chance that the game is going to be successful. So that's what it means to be a AAA game. So we took our interpretation here of what would be the most important features to add to a Battle Royale demo to mean it is a AAA one. So I would highlight here a few things like the super fast-paced thing to differentiate from an MMO. Server authority, it's super important. So you don't want to have, you want to be a little bit competitive. It's compared to, let's say, other more loose games. So going down to the technical details of what this makes to build such a game. In this slide here, we listed some interesting gameplay features. And why is that? Why is this also important? So when making a demo like this, if we're claiming that this is a new threshold of what is possible to do, it is super important for us to benchmark, including every single gameplay element that a player expects. And this is for two reasons. So one is, of course, we want to highlight how you can actually implement these features with high accuracy netcode. And on the second, a second reason for this is that we also want to make sure when we claim some benchmark numbers, we're doing so with a game that is full of actual features expected in the game. It's not like a synthetic benchmark that just puts 200 connections with some random characters moving around. So this is an actual complete game that has very interesting and detailed features that you would find in a retail game of such caliber. So I'd like to highlight here, for example, the detailed recoil patterns that you can muscle memory to counter, the fact that projectiles even pierce through walls and can damage characters on the other side of them. And we still also have this spectating and all the little rendering details like uncapped rendering rates and even hardware mouse smoothing capabilities that the demo has. But talking about netcode features, this slide here, it's an interesting history of what it means to do this kind of games. So although we're in 2022, you may think things are different now. And if you consider the evolution of internet capabilities, bandwidth may be plenty now. So it's not necessarily a big problem. But latency hasn't changed much over the past 30 or 20 years. And the reason for this is that we're still, of course, limited by the speed of light. So this means that the fundamental ways we use to develop games have not changed. And one of the most important aspects, if you want to do a competitive, high immersive game, is fast response times. So that means you need to have client-side prediction. So where are the roots of these techniques? So as incredible as it may sound, so the roots of this come back from the very first very good games that implemented these features. So I'm talking here about Tribes, Counter-Strike, and Quake 3, for example. So this netcode demo is built on top of Photon Fusion. Photon Fusion is a modern, state-of-the-art implementation of all these basic features that make good state transfer netcode on top of Unity. One thing we wanted to make sure to have with Fusion was to use what is safe and known by the teams. So Fusion works on top of Unity game objects, which means you can use the pipelines that your team is already accustomed to, and you can achieve the very best kind of performance possible by using it. This is a sneak peek of how you network data, and the Battle Royale sample uses these very same techniques all over the place. So there are three fundamental principles that you can use to synchronize game state. So first one is you can just assign networked properties to be synchronized. You do that using the attribute networked. That's step number one. Then step number two, you use an update callback to change your game state. You can do that from your server, but it's essentially just Unity code. It's similar to Unity fixed update, but it is aligned to the network ticks. And finally, you have optionally remote procedural calls that you can use to pass some occasional data. Normally, a client asks the server to do something like, I want to start the game with this following loadout, or I want to buy this thing, or maybe I'm looting this from this character here. So this is normally what you use RPCs for. You do not use them as much as the two above. Then I mentioned before that feedback is super important, and client-side prediction is the most important aspect of that. So wouldn't it be super complicated to do client-side prediction then? And the answer is the code you guys just saw already does client-side prediction. So you don't have to do anything else besides marking network variables and writing code aligned to ticks under fixed update network to have client-side prediction working. Automatically, this is going to run on the clients to predict what you want, or for example, for the local character, while data coming from the server is going to be reconciliated automatically for you and aligned to ticks, meaning that it will be smooth and accurate all the time. So this is the basic principle you're going to use. This picture here, you can always pause to take a look at this video later and see a bit more details on how this prediction loop works. On this next slide here, we actually have the full complete prediction loop. I'd like to highlight here that in blue, we explain here how rollbacks and reprediction, resimulation of previously predicted ticks works, while the green side shows how we are predicting new ticks. So everything is explained here. Of course, you can find these over the documentation, but it's essentially the principle that you have discrete tick simulation going on, and this is the basic fundamental way of building high accuracy netcode. So then, how can you use these principles and still run a game for 200 players at 60 of these simulation ticks per second? So the fundamental fact that allows this to happen is that servers only move forward. So servers do not actually do any rollback, only clients do rollback. So we have to guarantee that the performance of the server is capable of sustaining 60 ticks per second with the full load constantly, but it doesn't actually have to do any rollback or any complex operation like that. It's like a regular game moving forward, but it has 200 players. So contrary to some people may think, packaging data and using area of interest to send only data that's interested for one client to itself, to sell to it, and so on, is not the most the thing that uses most CPU. That actually takes about like 2 milliseconds only. It's also not like compensation, which some people may think that it's the what takes more CPU. Like compensation actually is designed for this sample. You have 200 characters with 15 animated hitboxes each, and this can shoot about 1,000 projectiles, everything under 2 milliseconds. So it's not really the most the thing that consumes more CPU. Surprisingly, what consumes a lot of CPU is moving the characters and animating them. So that's what actually has to be fully optimized, and that's why we write our own character controller, which is available as a separate add-on even, but it's also demonstrated in this sample for you guys to take a look at. And on the right here, this graph, we included it here because it's an interesting link between the technical aspects and hosting, because this is the raw results of a real test we did together with Unity's Multiplay. So this is this very demo running with 200 players connected, 200 clients connected, moving around and shooting on a server hosted by Multiplay, a bare metal machine in this case. And on orange, you see how long it took for each Unity update to run on this dedicated server, always below 60 milliseconds, meaning it was able to sustain from a single thread all 200 players stably over the course of the test. So I'm going to let Dan talk about this later on, but I just wanted to bring this graph here because it is an actual test done with the hosting that the demo also includes. And finally, on the client side, there are also interesting considerations to make. So obviously, Fusion also includes network culling, meaning that you have all control about what data goes into each client, either based on areas of interest for each one of the players, but also based on other forms of interest management. For example, other players do not need to know particularities of your inventory or for which extra weapons you have. So those things can necessarily, they may only be sent to you, for example. Other players do not need even to receive that data. That both saves bandwidth, but also adds some security aspects to the implementation. And again, this also saves performance. But the most important aspect for performance on the client side is the fact that prediction is done only for the local character, because again, character controller and animation are the most important aspects in terms of CPU consumption. So predicting only the local character is the fundamental principle for this. Everything else you see using accurate snapshot interpolation, and because Fusion has built-in lag compensation, it means that what you see is what the server is going to compute for example, projectiles when doing lag compensated shots, either ballistic projectiles or hit scan weapons. I'd like to invite now Dan to come back and continue with a going world scale with all this.
All right, thank you, Eric. Okay, so we're in a great place now, right? We've got our AAA grade multiplayer game ready to provide that engaging, visceral experience up to 200 players per match. But how do we reach all of those players around the world who are pumped to play this game? We need to provide these dedicated game servers. As Eric was describing, we've got a server authority model here. We need to get those servers into regions where our players want to play that game. You know, we're limited by that speed of light, so the closer we can get those servers to our players, the better chance we have of giving them a good experience, free of lag, free of latency, all those things that are going to affect the gameplay experience. Now, 200 players per match, it's not trivial. If that game goes big, as all developers will hope, we have an opportunity to bring huge amounts of concurrent players together. And when we need services and infrastructure, they're going to be up to the task. A multiplayer game lives and dies on the reaction of the player base. We've all seen how passionate players can be. They want to be able to find matches quickly, they want them to be fun, and they want them to be fair. And this is where we made use of Unity Gaming Services alongside the BR200 sample to demonstrate how those problems can be solved. So Unity's answer to dedicated game servers is called game server hosting, formerly called Multiplay. So the success of your game server shouldn't depend on your team having infrastructure or server scaling experience. Now, this is what game server hosting is designed to solve for. The platform is proven. We've worked with studios such as Respawn, Inner Sloth, Huge Calf. Multiplay has provided reliable server availability, on-demand scaling, and cost optimization to those studios, among others, at a massive scale. Now, this is a hybrid and a multi-cloud solution. And what I mean by that is the platform can take advantage of both bare metal and cloud servers for your games. Now, as Eric was describing, we've benchmarked this on bare metal for absolute performance. And while this is a Unite presentation and BR200 is a Unity game, we should call out that Multiplay is an engine agnostic platform. It is designed to provide a great developer experience, irrespective of game engine or platform. So whether your players are on PC or console or mobile, game server hosting is here to make that work for you. And as we've seen, 200 players in the same match at 60 Hertz, it requires capable hardware to run that simulation. And when you're deciding where to host that game server, you're typically faced with these two choices, and that's bare metal or that's cloud. And the Multiplay platform can make the best of both of those worlds. Powerful, cost-effective bare metal servers can be used from up to 200 data centers around the world, and that's going to give you super fast CPUs, lots of memory, terabytes of bandwidth included in your machine cost, and those are ideal for hosting a game like BR200. But assuming your game is successful, you will run out of server space at some point. You won't be able to physically rent or rack those machines quick enough to meet your demand. Cloud is going to scale much better, but it is expensive compared to bare metal. Your actual mileage is going to vary depending on your machine's specifications and your game types. But in general, one of your cost drivers is going to be network egress. And that's your sort of data egressing to the internet. And game server hosting is solving these problems for you because it's a multi and a hybrid cloud solution. We're integrated with major cloud providers like AWS and GCP, as well as those 200 bare metal data centers I mentioned earlier, and that gives you a global network of server capacity. The platform is going to blend bare metal and cloud together into availability regions within which we'll place the game servers to take advantage of your cost-effective bare metal, your performant bare metal, and the scalability of cloud, so we keep servers up, keep players in the game. So pulling back a second, the headline here is that BR200, or any game using Photon Fusion for that matter, will run out of the box on Unity Game Server Hosting. And as you may know, Eric and the team over at Exit Games run their own set of cloud services called Photon Cloud. Now, through the collaboration on BR200, we were able to make the best of both of these services, Photon Cloud and Unity Gaming Services. Photon Cloud is going to handle the management of lobbies and sessions via its services and APIs. Both servers and clients are required to interface with these APIs as part of the Fusion package to connect to each other. And lobbies and sessions are namespaced with a Photon application ID. So looking on the other side of this diagram, dedicated servers hosted by Unity will register sessions within Photon Cloud. And we made this possible through the great new multiplayer features recently added to Unity Gaming Services. Among those, we developed a brand new API-driven onboarding flow with a brand new powerful user interface to get your game server uploaded, configured, and running. And we've taken the years of experience and studios we've worked with over the years to bring that proven hosting technology to your fingertips with these developer-focused features. You can upload your game server build, specify where you want those servers running, and how you want them configured. You need 100 Battle Royale servers in North America. You need 50 Capture the Flag servers in Western Europe. All of this is achievable within minutes with Multiplay today. Another awesome feature we shipped this year, which is relevant here, is the Game Server Software Development Kit. Now, the SDK can be dropped into your game server runtime, and that allows you to get up and running in only a few lines of code. And that was crucial in getting BR200 integrated with game server hosting right away. It was handling requests from our matchmaker, reporting metrics back to the platform, and making that a really easy process of integrating the game. So if we deep dive the SDK a little bit more, at its simplest form, this is a package that integrates your game server with our platform backend. Now, this is a drop-in replacement for previously having to write the bootstrap code yourself. It allows you to ship metrics on your game state. For example, the number of players currently in a match. And those are critical insights into the popularity and the operation of your game. And you can see all this in the Unity dashboard from that data service from the SDK. The other headline feature of the SDK is the allocation lifecycle. Now, the way to think of an allocation is the unique identifier for a match or a game session. It ties an instance of your game server to a request from a matchmaker. The SDK will allow you to register a callback function in your server code to trigger when you've allocated a game server from a matchmaker. You can run your startup logic, load assets, get your match running, and ultimately start accepting players. And just to show you how easy it is to get up and running with the SDK in Unity, you just need to install the Multiplay package via the Unity Package Manager. At the moment, as you can see, you need to install it by name, so com.unity.services.multiplay. In a future build of the editor and the package manager, it will be automatically discoverable, but for now, you can still get up and running with it. And then it's just a matter of registering your callback function with the event system, as you can see on point 2. Really simple. On allocate, we register our custom function, and then that can do any startup logic we need. Of course, this is really abridged code. Please don't try and run this. We've got much better sample code over on our documentation website, and that'll put you in a really good place to get up and running with this. The most exciting part of bringing this project to life was being able to get players together across the services provided by Photon Cloud and UGS. And this is where Unity Matchmaker entered the party. So with online games, who you end up playing with is going to have the biggest impact on whether that game experience was positive or whether it was negative. And that's particularly true for in a competitive game like BR200. And we're going to dig into how Unity Matchmaker does this in a moment. But for the purposes of this overview, the matchmaker's job is to get our players onto a BR200 server. We generate a unique match ID and share that out in 2 directions. It goes to the players and it goes to the game server. The game server is going to register itself into the Photon session service, which in turn makes that session available to players via the lobby system. All this to say is those players simply need to load up BR200, they hit quick play, and they get put into a match that is the best possible one for them. And that is ultimately what Matchmaker is doing in this role. It's doing that in a number of seconds as a really quick process. So if we pull back a second and think about what makes Unity Matchmaker such a good fit for this use case. And as with Multiplay, Matchmaker has an API-driven onboarding flow. It's got a powerful user interface and all of that to allow you to configure your matchmaking experience to come up with a number of game modes, player numbers, or even custom rules for your matchmaking. Now, it's a hugely scalable solution. It works just as well for tinkering with a sample game or launching at world scale. And that's because it will scale to 0, but it will also be able to scale up to large battle-tested volumes. So this particular solution has been used by studios like Respawn and Team 17 to launch some pretty big titles there. And as I say, it will scale to 0 when you're not using it. So it's hugely cost-effective also. Whatever your game type or your number of players or your modes or your maps, Matchmaker's got you for this. There's a declarative rules engine that allows you to build discrete sets of queues and matchmaking requests called tickets, pools of players, and rules on how to group those players together. And we've got headline features here like backfill, which will also be at your fingertips that I'll dig into on the next slide. So let's talk about this in a bit more detail. So here is a very rough high-level diagram of how matchmaking works in this case. So queues. Queues are a sort of traditional approach for separating our players into compatible sets for matchmaking. Here we've got 2 queues. We've got one for Battle Royale and we've got one for Deathmatch. And on the left-hand side, we've got the incoming tickets, requests for games by players. Other types of queue we might want here would be maybe a capture the flag queue, or maybe some sort of platform-specific queue if we have cross-play requirements for our game. But in this case, we've just got the 2. Inside our queues, we've got pools. Now, pools are a dynamic service-side system for doing additional segmentation of players in a queue. And that's going to allow you to isolate certain players on the fly, run different rules for those players, or even target a different server, depending on what those players need. Each queue is a default pool where the majority of our players will end up. So in our example, we can see ticket 1 goes to the default pool and is loaded onto an available Battle Royale server, along with all the other folks who submit tickets of the same type. They're grouped up, placed on that server. But also within this pool, we have a beta pool. Ticket 2 has an attribute which indicates the player is using a beta version of the game. As you can see, it's 1.3 beta. So we can place them into a separate pool along with other folks with the same attribute on their ticket and make them onto a different server, onto a beta server that has all the new features for that game version. Maybe these are your QA testers, for example. And then finally, on the bottom right here, we see something a bit different. Now, this is a multiplayer server happily backfilling players. And that is letting the matchmaker know that a slot has opened up on that server, a player's left, they've disconnected for some reason. And depending on your game design, backfill is a really critical function for keeping your servers full and your players happy. A lot of matchmakers have that feature, and Unity Matchmaker is no different. And this allows you to put players onto an already running server instead of creating a new one. And that can be great for optimizing your resource usage and also reducing player wait times, allowing them to jump straight into a running match rather than waiting for a new one to begin. Now, for the Battle Royale mode that we talked about earlier on, backfill maybe isn't such a useful feature. Last player standing obviously doesn't want new folks joining into the match and sort of ruining that gameplay experience. But for something like a deathmatch or a team-based game, you want more people in there. You want the teams full. You want the game to run as long as we possibly can and have that sort of more fun experience. And that's what you see here enabled on our default pool. So to recap, all is to say, we've got a fantastic AAA grade BR200 sample here. We've loaded that up onto Multiplay. We've got Unity Matchmaker in the mix as well. And from a game point of view, from a player's point of view, they load up the game, they hit quick play, and they're in the match. Thank you.